AS Paper 1, Specimen 2. Question 1. This question is about toxic chloroalkane X has a boiling point of 40. Determining the MR by injecting the sample of X into a gas syringe in an oven at 97 degrees C, 100 kilopascals. Results are here. Complete table 1 and table 2. So the mass of the hypodermic syringe before injection, after injection, subtract the 2, you'll work out the mass of X injected, 0.270. Volume on the syringe before injection, volume of X in the gas syringe after injection goes up to 105, so the volume of X is 105. X is known to be one of the following. Determine the MR of X and identify which one it is. Give your answer to an appropriate precision. The gas constant R is 8.31. So if you're given a gas constant, you're going to use PV equals nRT, where you've got pressure, you've got volume, you've got N is the number of moles, you've got the gas constant R, and you've got the temperature in Kelvin. So PV equals nRT. So you could rearrange that. We've got to try and work out N, the number of moles. How do we know that? Because we're given a pressure of 100 kilopascals. We're given a temperature, 97 degrees C. We've got the gas constant, and we've got a volume as well. So we've got everything we need apart from N. So we're going to work out N. I could rearrange N, so N would be PV divided by RT. The pressure is 100 kilopascals, but it needs to be in pascals. So if you take a high unit, a large unit like kilopascals, down into a smaller unit like pascals, you multiply by 1,000. So 100 becomes 100,000 pascals. Multiplied by the volume. The volume is 105 centimeter cubed. That needs to be in meters cubed. So centimeter cubed going up into decimeter cubed, you divide by 1,000. Decimeter cubed going up into meters cubed, you divide by 1,000 again. So it's 105 centimeter cubed divided by 1,000 divided by 1,000 again. So that gives us the volume now in meters cubed. So that's pressure times volume, divide by RT to leave N. R is 8.31, and my temperature needs to be in Kelvin. It's given as 97 degrees C, so I need to add on 273, which comes out to 370. I can work out N, 3.41 times 10 to the minus 3. So now I've got the number of moles of gas. So now I can work out MR. So moles is mass divided by MR, so MR is mass divided by moles. The mass is 0.270, and it's in grams. 0.270 divided by the number of moles, 3.41 times 10 to the minus 3, 79.1. I'm looking at the gas constant here, 3 significant figures, so I'll keep this to 3 significant figures. It's difficult to exactly determine how many significant figures you should have it to, because they're all at slightly different significant figures, but I'm going to go with 3 significant figures. That seems reasonable. Suggest a reason other than apparatus inaccuracy why the MR value determined from the experimental results differs from the actual MR. Explain your answer. And this is for 2 marks. So what could have happened? So when we've injected the X into the syringe, into the gas syringe, the syringe might already have a little bit of gas in there. Maybe it's not completely empty. So maybe you've got some air in there as well. So maybe your volume is bigger than expected. So the volume of the gas from the syringe contains X, but probably contains a little bit of air as well, a small amount that's already in the syringe or in the end of the syringe. So V is larger than expected because it's got a little bit of air in there. So now if we look at V being larger than expected, pressure times volume equals N times R times T. So if this side is larger than expected because V is larger than expected, then the number of moles is larger than expected. So if the number of moles is larger than expected, then MR is mass divided by number of moles. So MR is mass divided by number of moles. If number of moles is bigger than expected and it's a divide by a big number, then MR is going to be smaller than you expect. Suggest with a reason an appropriate safety precaution could take using toxic chloralkane. You'd put it into a fume cupboard. It's a gas, so you'd use a fume cupboard because it's toxic. It's a toxic gas.